For this example, we're trying to prove that triangle ACD is congruent to triangle BCD. So one of the first things that they actually told me was one of the angles, so I'm going to use that as my first given. So I'm going to say angle ACD is congruent to angle BCD, and that is because it was given to us. That's known to be true. So angle ACD is congruent to angle BCD, which basically also tells us, if we cared, that angle ACD is a 90-degree angle. They also told us that this was perpendicular. That wasn't up in the given, but it's in the picture. But really, I'm just trying to prove that two triangles are congruent, so it doesn't really matter that it's a 90-degree angle necessarily. It just matters that these two angles are the same. And they would have to be. If this is 90, they are on a line, so they're a linear pair. So it has to add up to 180. So either way, they're the same and they're 90 degrees. All right, the next thing that I've been given is that AC is congruent to BC. So if I go to my picture, I know that AC is the same thing as BC. So if I look at what I have now, I've got a side and angle, and then I need one more thing. And if you look right here, CD is on both triangles. So I'm going to use that as my third item for proving congruence. So I'm going to say CD is congruent to CD. So I have reason number 1 is given, reason number 2 is given. The third thing is just the reflexive property of equality again. So I'm going to say it's reflexive. It's congruent to itself. And what I have now is a side, an angle, and a side, and then in the same order, a side, an angle, and a side. So I can go straight to triangle ACD is congruent to triangle BCD. And then the reason for that would be the side, angle, side SAS postulate.